The fragmentation debate. Is 3I Atlas breaking apart? The world of astronomy is currently experiencing a wave of intense discoveries, with new updates about 3I Atlas arriving almost daily, keeping the global scientific community on high alert. And one question now echoes across research institutions worldwide. Is 3I Atlas breaking apart? This question gained urgency after the November 9th observations, which revealed unprecedented features of this interstellar object. The data showed powerful material jets extending enormous distances into space, displaying characteristics that suggest possible active fragmentation. The scientific community is split between fascination and disbelief. Observations indicate that the sunward-directed jets reach nearly 1 million kilometers, while those facing away stretch as far as 3 million kilometers, roughly 7 times the distance between Earth and the Moon. The evolution of these structures adds weight to the fragmentation theory. Back in July, the Hubble Space Telescope detected only a faint, luminous cloud around the object. But by November 9th, the jets had grown to 3,000 times that size, suggesting a dramatic transformation in a short time frame. Historical precedents. Fragmentation in action. The case of Comet Shoemaker-Levy 9, discovered in 1992, provides a striking precedent. After approaching Jupiter too closely, the comet fragmented into 21 distinct pieces due to gravitational forces. When those fragments slammed into Jupiter in 1994, they produced atmospheric disturbances visible from Earth. The resulting impact scars were larger than Earth itself. Another example is Comet Holmes, which in 2007 exhibited a sudden and explosive brightening, accompanied by a vast expanding cloud. Both Holmes and Shoemaker-Levy 9 support the idea that comets can undergo rapid, violent fragmentation, offering clear parallels for interpreting 3I Atlas. Jets, defying logic. Normally, comet tails are blown away from the sun by solar wind. These tails act as propulsion systems that eject particles and gas at over 1.3 million km/h. But the sunward-facing jets on 3I Atlas represent a major anomaly. To maintain their structure against the solar wind, they must be composed of extraordinarily dense and powerful material, possibly emitted by multiple active fragments. Such jets are rare, but not unprecedented. Still, their scale and persistence challenge existing models. Notably, physicist Avi Loeb's analysis reveals striking discrepancies in mass loss estimates. The mass paradox Loeb estimates that 3I Atlas is expelling 50 billion tons of material every month, yet its total mass is calculated at approximately 33 billion tons. A clear paradox. How can an object eject more material than it weighs? This inconsistency points toward fragmentation as the only viable explanation. In fact, something similar happened with Shoemaker-Levy 9. Once fragmented, its total observed material exceeded original mass estimates. The most likely cause is differential solar heating, where one side of the object gets intensely heated while the other remains cold. This creates internal stress, and eventually catastrophic rupture, just like glass shattering under pressure. As the object breaks apart, its total surface area multiplies, accelerating the sublimation of ice and release of gases. If 3I Atlas has broken into several pieces, this would explain the 7 distinct jets observed on November 8th, followed by the expanding structures seen on November 9th. Each fragment would contribute individually to the material ejection, matching Loeb's mass loss estimates, and reinforcing the active fragmentation theory. But is it confirmed? As of now, no definitive confirmation of fragmentation has been established. This is crucial. If 3I Atlas turns out to be intact, yet still capable of producing massive, high-velocity jets, then we may be witnessing a completely new class of astronomical object, one that defies conservation laws and conventional astrophysical principles. The orbital mystery. Fragmentation isn't the only strange behavior. 3I Atlas follows a retrograde orbit, meaning it travels in the opposite direction of nearly every major body in our solar system. From above Earth's North Pole, all planets orbit the Sun counterclockwise. But 3I Atlas moves clockwise, a trait seen in only 1 to 2% of known objects, typically small captured moons. What's even more bizarre, its path is perfectly aligned with the ecliptic plane, the flat disk where planets orbit. Most interstellar objects enter the solar system at steep angles, but 3I Atlas approaches from within the same flat orbital plane. The chance of such alignment is 0.2%, or 1 in 500. Echoes of Oumuamua. This combination of rare features, retrograde orbit, ecliptic alignment, mass loss anomalies, and directional jets, reminds many scientists of Oumuamua, the first recognized interstellar visitor. Oumuamua exhibited an elongated shape, rapid brightness variations, and non-gravitational acceleration that couldn't be explained by normal comet behavior. Avi Loeb controversially proposed that Oumuamua might be artificial, possibly a solar sail driven by radiation pressure. That idea was debated heavily, but never disproven, and now similar questions are being raised about 3I Atlas. Unlike Oumuamua, which was only a few hundred meters long, 3I Atlas is enormous, over 1.6 kilometers wide, with billions of tons of mass. If it is fragmenting, the consequences are vastly more observable and significant. A new kind of object? While none of these features alone would be definitive, their combination makes 3I Atlas one of the most enigmatic objects in modern astronomy. The fragmentation hypothesis currently provides the best fit for the observations, but confirmation is still pending. If confirmed, we may be witnessing the real-time breakup of an interstellar visitor. If not, then something entirely new is unfolding, perhaps a class of object we've never seen before. Either way, 3I Atlas is rewriting the rulebook. Its behavior challenges our understanding of how objects move, disintegrate, and evolve in space. Every new image, every update, brings us closer to understanding whether this is a natural cosmic relic or something far more mysterious. To stay informed about 3I Atlas and other extraordinary space discoveries, consider subscribing and liking this channel. We're entering a new era of cosmic exploration, and you're watching it unfold in real time.